Ladies and gentlemen, welcome to my presentation. My name is Arwin. I'm a mental mechanic, a physicist, a cosmologist, theoretician, and a recluse. Yes, this is the very first presentation I'm ever doing in front of an audience. Thank you, yes, I have some papers here in front of me because I really need them. I'm very familiar with the material I'm going to talk about today, but I'm used to doing this in English on a daily basis for 10 years. So for me, it's a reasonable challenge to be able to present it all in Dutch in a way that's still understandable. So I'm going to do my best for that today. Right. On the internet, I'm known as Arwin. I have a YouTube channel, also with the same name. Is there anyone in the room, by any chance, who has heard of my YouTube channel? Raise your hand. Okay, yes, you can leave the room immediately. It's a joke. If you know my YouTube channel, then you know that I regularly throw people out of my chat. They can be very difficult, right? Okay, I'll start with this thing. Here the presentation is also called Ball Earth. How do you get there? And that is, of course, a Dutch play on the word because it is yes, how do you literally get to that Earth? And how do you actually think of it? So I'm going to start with that with the first part of the presentation, which I will go through fairly quickly about how did they design that birth for us? How did that happen? Because it has taken a lot of time. There have been a lot of developments in it, and I'm going to summarize that as concisely as possible, because in principle I could do a 3-hour presentation about that with a lot of mathematics, which I don't feel like doing at all, because I'm not very mathematically oriented, and it will also be noticeable during the presentation that I don't mention that many numbers, and so I'm very much into descriptions, right? And that's where I'll leave it. Okay, then I'm going to put down General Flat Earth K, and I also have some videos to demonstrate what would I consider to be the evidence for the flat Earth. There is a lot of it, and then if there is still time left, then I will continue with my model, and my model is very unusual. That's not something that a lot of flat Earth people are generally concerned with, because the most well-known, of course, is the Disney Gens map. All flat Earth people know that that's what you encounter most on YouTube videos and everything, but I do not completely agree with that, and then I'm going to explain why. But good, let's start with the ball Earth. Now, what we all hear maybe also at school, I don't know in how much detail that is, that everyone gets to learn that, but the story starts with Aristoteles. Maybe heard of Aristoteles, are from ancient Greece, put sticks in the ground at certain locations, and because of the shadow of the sun, he determined that if the ball, like the Earth, is a ball then, and is surrounded by the sun and the stars, then the shadow of the sun will have a different angle with each distance on the Earth, and so it was assumed that now if the ball, like the Earth, is a ball, then yes, then those shadows should end up in that certain way, and it did. And that was, as it were, the first step, of course, that is based on a presupposition. And yes, if the ball is Earth, or sorry, I keep turning it around, if the Earth is a ball, is of course not proof that it is a ball, but it is a good correlation. Okay, that's where it starts then. There was the so-called Alberoni of Persia, who was sent on assignment to go to a mountain, to go there and then see how far is the horizon now? How far away would that horizon be? Because if the Earth is a ball, then there should be a certain limit to how far you can see, and that has also been calculated. There are formulas for that, and there are ball Earth believers behind the horizon has a certain geometry, and so he went to a mountain and looked, and with a wide margin about 10 error, in that he made a determination. Yes, I think the horizon is so far away, and we consider that good enough for a bar Earth. And a lot later, again in the Renaissance, or just before actually, came Copernicus, mathematician, an astronomer who came up with the idea of, yes, all those celestial bodies that seem to revolve around us. Yes, how about now? Are we really, as the Bible previously made it to everyone, as it was taught, are we the center of the universe? Or are we perhaps not the center of the universe? Is the sun the great light source? Is that perhaps the center? And through mathematics, he managed to work everything out, so to speak, that he could make that argument. And we are told at school that it caused a lot of trouble with the church, which at the time was still a considerable authority. And yes, if you went against that, then you could get in trouble. But what they don't tell you is that that same person and a lot of others were also actually protected by the church. They were not persecuted at all. They were paid by the church, and then not directly, not openly, but high-ranking connections, the oligarchy of the time, that neighbor, all those people, because it's an expensive hobby if you have to work with expensive telescopes all day long, and you're dealing with mathematics, that's expensive, and you don't just get that. So that's where it started with heliocentrism, and that's what we're still dealing with now. The church gave in. It's supposedly that's what we were told in history, and then it was determined, okay, it revolves around the sun. It doesn't revolve around the earth, but that was ultimately purely mathematically thought out DS. Because it all just revolves, and you can put those patterns of those rotations in the formulas in different ways, but in the end, yes, we don't even know what it is. We don't know what the sun actually is. Well, okay, we'll move on to Copernicus. There are, of course, many more astronomers who have been there who have all determined small details, but an important newcomer was Isaac Newton, and he came up with the idea, why do all those things revolve around each other and around the earth, and the earth around the sun? Supposedly, well, that happens because of gravity. That has the same effect of an object falling down. Why? Well, because it supposedly has a gravitational pull due to the mass of another object that he came up with. He worked that out expertly. That was reasonably successful for the time, but yes, in the end, when he realized what was happening with all that information, then he did not like it that much. And he also wrote a letter to a colleague, and he has that is on record. You can find that on the internet, the letter that's just there. Yeah, please don't attribute that law of gravity to me, because I think it's completely ridiculous to present the idea that an idea that is just a fabrication would be presented as real. Newton himself thought that was ridiculous. That's official, so fact to know well. Okay, then we continue. That became part of the heliocentric model that was adopted, and then there were other issues. Namely, yes, all those celestial bodies, how far away are they? Because yes, you see, no bright light, oh, this is very bright, less bright sun, of course, a lot the stars and the planets a little less bright, but yes, How big is it now? How far away is it now? And it turns out to be very difficult, if not completely impossible to determine that, because in theory, yes, you can determine how big something is because you know the distance, and you can determine what the distance is because you know how big it is. Then you have an angular size, and you can compare with the distance, and then you change that distance, and then the angular size also changes at the same time, and then so you can determine how big it is. How far away is it, but with information about both the distance and the angle, or the actual size that's missing, so we don't have that, then I'd better ask you. We still don't have that. But then Arwijns, Dutchman, who came up with the idea, yes. But if we just determine that Venus is exactly the same size as the sphere of Earth as we have imagined, then we can use that as an anchor to determine how big everything should be. So he determined, and everyone went along with it in the whole astronomy club. Yes, if that Venus that we see in the sky is exactly the same size as Earth, then we can determine a size with that. So then, yes, that was determined. And then suddenly a scale model came out of that appearance from which it was determined, okay, the sun is so big, has so much distance, it has shifted over the centuries because first the sun was supposed to be much closer and eventually it ended up at 93 million kilometers, so to speak. But that is all because of Arwijns, because without him there would never have been any determination about how big and how much distance that is. All should have been, so to speak. So that's very interesting to know that, at least as a flat earth researcher, I thought that was good. From there, you have a nice heliocentric concept, but what is actually in the earth? Well, there isn't a specific person who is really, but it's completely attached to one name, so yes, there have been several researchers who looked at it a bit like, okay, what could be there? And then they finally came up with the idea, molten iron core. Has anything ever been proven about that? No. Not all. There has only been speculation about it, a lot of speculation. Ultimately, in the 20th century, there is still the deep coke ball in Russia. They drilled and they tried to predict what is there based on P waves and S waves. That's the technique where sound is sent downwards, and then, based on the reflection patterns, you can determine approximately what is there, and that works reasonably well for about 100 minutes, and then it's completely chaotic. And that also became apparent during the whole process that, yes, every time they made a prediction and then they dug deeper, and then it turned out that absolutely nothing was right. Really, at every step, absolutely nothing is right. So yes, molten core, that is a concept that actually doesn't have much support, but it is only kept up to date a bit. And meanwhile, there are also more modern speculations that, oh, maybe it's not a molten iron core at all. Why would it be? Because molten iron is not magnetic at all. So there is absolutely no reason that it should be like that, other than, yeah, maybe that has something to do with lava, but yeah, but anyway, in the early 20th century, they discovered through mathematics that gravity does bring some problems with it. Newton mechanics, yeah. There are all sorts of strange things that happen with it, including, perhaps quite well known by now, the three-body problem. Three-body problem, namely, if they have two bodies that have an attraction to each other, then it is reasonably easy to predict how they will move. If there's a third body, then this is totally hopelessly unpredictable. It is so unpredictable that it is notorious that with only three bodies that should have an attraction to each other, you cannot predict that mathematically. What are they going to do? And that's still an ongoing problem. And that's why it was deemed necessary to leave Newtonian mechanics aside, and Einstein came in to solve the problem by saying, that's not an attraction at all. Matter doesn't attract each other at all. That has nothing to do with it. No, what matter does with it is mass space-time. Oh, space-a-tie. What is that? Yes, space-time is a concept that does not occur in 3D reality. It's a completely invented medium that's purely mathematical and actually has nothing to do with physical reality, but mathematically you can do all sorts of things with it. It's all very funny, but it's pure mathematics. And with that, the problem of gravity, among other things, the three body problem was supposedly solved. So yes, then problem arose. What is that? What is the bending of time-space? Well, and what we got in return, that's a story about thought experiments of relativity, like, yeah, but if something falls down, maybe it does, then fall down all, maybe the earth falls up towards it. Oh, if you just think differently about it, if you think about it, you can get really confused until you stop asking questions about it, right? That's a good solution, right? That's how it works, right? With heliocentrism, it just makes it so complicated that you don't understand it anymore, and then everyone stops asking questions, and then everyone goes back to their daily lives. So then Einstein came up with gravity, and then eventually it continued into total astrophysics, because these things were all just assumed. That's how it works. The sun is central. Gravity is the bending of space-time. We determine how big all those celestial bodies are. It's all decided. We all know it. And now we can continue with total speculation about those things. And then Lemer came along with the Big Bang Theory. Our Catholic priest, a very strange source of course for something like that, Z. I think, yes. But the Catholic Church had fought against those strange, wizarding ideas of the helicons and astronomers, right? Well, it turns out that a lot of those people actually do work for the church and are now very happy to cooperate. They really want to be a pioneer now from the Vatican, and so I came up with the idea of the Big Bang. Everything suddenly appears out of nothing, out of an infinitely deep black hole, and boom, everything explodes out of nothing. It slowly forms, but it comes together. You get the suns and the planets, and yes, it comes out of nothing. Of course, a totally strange idea. What, yes, how can something come out of the thick? There is no demonstration of this physically. And it is also, yes, it conflicts with entropy, the natural law of entropy. Everything changes in one direction, and it never changes in the other direction. High pressure always goes towards low pressure. It always radiates to a colder place, and it never goes the other way around. And yes, that same entropy makes that yes, how can something come out of nothing? That is simply not possible. So yes, that was with the Big Bang, and eventually we ended up with things like dark matter and dark energy. Where do they come from? Dark matter, dark energy is an immeasurable, undetectable substance that supposedly has to be in the universe. And why? Because otherwise, the mathematics of gravity would not work by a large margin. Big hole in the whole mathematics of how all those planets and suns and the whole galaxy should now keep together. Well, that doesn't work, so we have to come up with dark matter, dark energy mathematically, but you can't measure it, so you do not have to ask about it anymore, but then it works mathematically anyway, and that's what they just say when you ask about it, like, yes, why? Dark energy? How do you know there? Because if it would, we would be wrong. That's what they Say then yes, so it must be true, because they can't misunderstand. Of course, yes, well, and that's a quick summary of how the ball earth was invented for us and what is still being propagated as official truth according to governments and curriculum in schools. So that was the first part of the presentation. In addition, yes, maybe you already had a hint of the things I've told. I am personally convinced that the bow earth is not a revolution against the church, against the I have nothing against Christ, but against the Catholic Church, but it is actually secretly a revolution of the church, a next step, because what they did first, of course, is create their own form of Christianity with all the additional books and things. Well, if you know anything about it, of the Catholic Church, then you know there are all these extra books and descriptions of hell and such. They all made that up. That has nothing to do with the original. And so they created an alternative from Christianity, which they also imposed, seriously persecuted other Christian communities of the time. Kadar, among others, they simply completely exterminated because he doesn't want to admit that the Catholic Church had any authority. So they got rid of all that. They imposed their Christianity. Of course, Protestantism emerged from that as a counter-reaction, but yes, those Protestants also absorbed many of their ideas, and in that way, Christianity as we know it is actually a consequence of Catholicism to a large extent, along with Judy's changes to remove the central authority of the Pope, because that goes very far. Of course, I think, especially the Dutch, that's nonsense. Then one man would be a representation of God. We all have that connection ourselves, so to speak, but that is the Protestant idea roughly, but well, it didn't stop with them changing Christianity. After that, they wanted to go a step further. They wanted us to completely get out of it and find the idea of God and Christ outdated. And so, over the centuries, they gradually gathered astronomers and experts together to create this image, the new religion for us. So first, they undermined Christianity with their own version. Then they told everyone, yes, it's just faith. It's not real. It's just a belief that we believe, and that's good. We feel good about that. The community in here, heliocentrism, that's actually real. Science, that's actually real. And now you see the Pope saying that nowadays. That's just absurd when you think about it. He would have fought against these people and persecuted them in the Middle Ages and the Renaissance, but now he's an advocate of it. Yes, that's suspicious. I think, yes, good, but I won't go into that too far. I'm convinced that the ball of earth is a new religion that stems from Catholicism. They have too secretly incorporated, and it is now the new world religion. And yes, as a real world religion, what makes a world religion a word religion? Well, that is that everyone is convinced that it is real, because a religion is not a belief, a story that you like that suits you. No, that isn't about, that is your reality. That is the religion. Ball earth is a religion, and that is how it was made. Okay, that was the first part of the presentation. If anyone has any questions for clarification, criticism, of course, but I prefer that for afterwards. Is if anyone has a question for clarification, I would like to hear it all. Clearly, especially continue. Okay, jowl time still. Be 10 minutes, no until what time? Are we allowed hours? Total 1.5 hours. Hard you until what time? Yes, yes, but it is I am only 10 minutes and busy. Know who you still have an hour already been? Busy for an hour. Still have, oh yeah, I just wanted to wanted to, okay, no, I have no idea how fast I'm going. I've never done it before, but I did this in 10 minutes, so half an hour. I think half an hour, yes, no, we're busy for half an hour. Oh, okay, well, yes, perfect. Then I'm on schedule. Oh, okay, when we're going to a better picture because I think you've had enough of that, Dad. There, yes, I'll leave it. That's, go well was that was Earth models. This, yes, so this you probably seen that before. These are all models of different world religions from antiquity and what they thought the Earth was, and then lastly, you see, of course, the ness of all Earth. It is very different from all those other religions, and that is just noticeable when you compare them. You thought we are all sitting on a flat plane. That plane is surrounded. Above us is the air, below us is the ground. And yes, that's what they thought at first. That's probably a sphere. And that's understandable if you think that, say, but that you are in a sphere, not a but. Yes, proving that is not so easy, but okay, Flat Earth, let's go to start. I'll first give you some background information about namely physics and the scientific. A method that is very important if you know how that really works. Because also through the media and all kinds of other situations in the world, know that there is a lot of messing around with what science really is, and that understanding of science that has gone through all kinds of changes of which we are just said. No, this is science. No, I think that this is it, and everyone has their opinion about it in this so-called scientific community. But yes, that is actually all a bit pseudoscience, because what is the scientific method now cause, in effect, is what it is about. But there are very critical components to the scientific method that are often very easily overlooked. Namely, it is necessary that you as an experimenter manipulate the independent variable. When you manipulate the dependent variable, what the which you have the idea that it causes the effect that you think it does. So then as an experimenter, you have to manipulate that you have to change something within the experiment before it, scientific experiment is like, and yes, then you always have a result from it, or manipulating the thing turns out that it shows that it either causes the effect what you thought it did, or it doesn't, the zero. So you always have a result, or it does it, or it doesn't. If you just observe something and you have an idea about it, you have a mathematical formula that describes what it does or whatever, then you haven't manipulated it, you only describe it, observe, and declare, and that is therefore technically not science. D is not physics, it doesn't belong to it, is pure speculation. And if you realize that, then you also find out that so-called sciences like astronomy and astrophysics are pure pseudoscience and absolutely do not belong to it. Is a speculative science. You look at it, you have an idea about it, you describe that idea, and you make a mathematical formula for it, and ooh, wow, he made a discovery. Well, that's nice, but it's not science. It's just observe and declare. Pseudoscience is important to know. Okay, then next the curve, because yes, if you stand on a ball, Earth that has consequences, that has geometric consequences, namely, if you are standing on a ball Earth, well, that means that if you look to the side, your view should be obstructed by that curve that is in the way. But is that really the case? Is that curve in the way? Just take the picture away. Come on, water, what should I do? Fuck you. Wait a minute, video, just scroll up or down. Sorry, I have to wait a moment. Yes, do that, but I'm going to show a video. Maybe you have seen it before. Pay close. Attention on the beach in England. Put the camera on its butt and quickly took it away because a wave is coming. And of course, I don't want the camera to be after. Okay, take a break. Yes, what do we see there? Oil drilling platform at respectively 6 and 9 phi. Miles away, that camera is on the beach at a height of the water. 1 vol was at 30 cm or so from the sea, and yet at that 1 foot height, can you almost see those things completely at such an enormous distance? If the Earth is a ball, how is it possible that you get to see that? Because if it were Gustav, then it would have geometry. Then, of course, that water would be completely in the way, and then you wouldn't see anything at all. So, this is an exceptional observation that has also been repeated. It is not the only time that this has been seen, which irrefutably proves that the Earth is not a ball with the geometry claimed by Hellicent. Because if that were the case, then at no time would you be able to see these oil rigs at that height. That is simply completely impossible. And there are sphere believers who firmly claim that this is the case because they claim, wait a minute. Yes, because they claim that there is something they call refraction, and perhaps you've heard of it, a mirage. That's what you can also call it, but yes, what is a mirage? It is a mirage, yes, a mirage, unfortunately, or refraction. The real refraction that exists within optics. Optics is a science. It is a science within physics about the workings of light and lenses and how you see things. Well, refraction is a real thing. How does that work? There is no picture for that right now, so now I have to make do with this. Fuck you. The angle of incidence of the light when it enters a hard barrier like glass, then the angle of incidence determines the angle of exit, and so the angle goes the light makes. An angle changes the angle of the light, but this happens, and that is how light can bend. Look in a glass of water, and it looks completely distorted because it is a hard barrier where so that angle of incidence and angle of exit are different, and that is called refraction. But here is the thing that only works if there is a hard barrier. Well, if you just look through the air, also cool, it is at 100 km distance, there is no hard barrier. You are all looking through the same material, it is all air. Maybe there is a little more moisture in that less, but it is one big homogeneous body that you look through, and now it is known among opticians, people who have studied optics, that refraction within a homogeneous medium is ignorable, or it is so small that it can just as well be ignored because it simply makes no difference no matter what the distance is. So there can be refraction take place, but that refraction will not lead until you see something at such a distance with a displacement of a few kilometers in Height that can never happen because there is a homogeneous medium that you look through it. Is not there are no glass plates in between that would cause it to bend upwards so that yes, refraction is not a counter-argument. Now they have an idea that it just happens that there is what they technically call terrestrial refraction, but this is a pure fabrication is a machine, as they call it in English, in which a mathematical formula has been created that is very complicated, very extensive, in which the radius of the ball of Earth is recorded, that is, in the formula. In other words, it is a mathematical formula that adapts to the curve of the Earth without this being proven or measured or anything that is simply injected into it. And yes, it is not substantiated by optics, so if you hear this, yes, but refractions, yes, but look, the thing on the side that bulges a bit so it is a mirage. Well, unfortunately, a mirage cannot say cause that you something that is behind a geometric obstruction, such as a mountain or a hill, if there is something behind it in your direct line of sight, in your direct field of view, never, but never, under any conceivable circumstances, be made visible by refraction. Then it can only be done with mirrors, physical mirrors, and otherwise. That does not happen so because there is sometimes air displacement at the horizon. But yes, what they do is only shift what is already in view a bit or push it down so that it is no longer clearly visible. Nothing from behind a mountain will never suddenly become visible due to optical effects such as refraction. That is very important to know, because once you understand that, yes, then you can just look with a clear conscience and everything is in its place vivo. I had a question because I see it. Well, that the horizon is even a lot further than the base of that left drilling tower. Yes, that is correct, but very simple. If that camera said something of you 1 feet, yes, 30 cm, so 30 cm, so then the horizon is, say, at about 1.5 quarter, then that horizon would even be in front of the right, say, but so it should be at who? Height before that, the base of that second windmill. Yes, that's right, yes, there shouldn't be anything visible at all. There should or even be the highest tower that is out. You wouldn't see. I can just press play, then he can show a little further. Another question. Yes, wait, that even further. Yes, I'll get to. You in a moment, because now he gets this. What bad outside? Yes, those things that you see, the drilling platform, they have a helicopter platform. If the Earth were spherical, then we could actually go and look at that platform. Well, we never know that. Then we can never look at the platform from the facts that, well, if it were to climb, then you would actually sink into the sea. So to speak, then you should be able to look at that platform. Yes. Almost, it's even worse. It should even be away from you, Stan. Yes. So you looked the bottom a little bit at an angle as if it were on a ball. Yes, but you never see that. You always just see everything directly from the side. And sometimes you even see above it. So yes, that's how it works. Indeed, yes, that was him. That was the curve. There is no curve. It's all as flat as can be, and the whole side view formula is also a trick because, yes, the side view ignores perspective, and that's the funny thing about a side view. If you just have a side view formula, a mathematical thing, then everything that is a so-called true distance. But yes, if you see something, then things get smaller with each distance. And if at some point it gets small enough, then you get the resolution limit of your eye that ensures that you simply can't see it anymore. It doesn't fit in the resolution, and then you see nothing until you take a camera and you zoom in, and then suddenly, because of the high resolution, you don't see those things that you can't see with the naked eye because it's all flat and it is no longer visible because it's behind a curve. It's no longer visible because your eye just can't pick it up. It has become too small due to perspective. That's another condition. So yes, that is the curve that doesn't exist. Black swan, this is called in my flat earth circles, this is called the black swan argument. Can I also explain briefly from Karl Popper that yes, a story from Renaissance? Karl Popper, his colleague, said, like, well, you know what, black swans, what a nonsense story. There are all white swans around there. Only white swans exist. So whoever says that about those black swans, that says, but what, all swans are white now, Karl Popper? He was like, yeah. And then he went to Australia, and then he saw a whole group of black swans. He thought, like, how I'm going to take them with him, and he takes a few black swans with him, then shows his colleague, hey, do you remember all the black all swans? Our white didn't think so. Here, you have a black swan. Here is your theory. Well, go away with it through the play it throughs over. Not all swans are white, and so also, yes, if there is an exception in an observation of the curve, if you actually see that, so like with this one, just play a bit, then he continues, if you have an observation where you see an oil rig at 1 foot height like this, then you know for sure that the geometry of the white swan is simply not correct because you cannot see behind a hill. That is simply not possible. So with that, the idea of the geometry is permanently dismissed, Black Heavy. Yes, that was okay. Just take a breath, can I? Fuck you. Take a sip of water. Geez, now time flies. Then we have to hurry. Right, then we will continue. Yes, I have already said quite a bit about it during the Ball Earth part of the presentation, but gravity, what is it now officially, is now, thanks to Einstein, the bending of time-space. But as I already said, then it is a thought experiment. Relativity, there is no force that takes place within gravity, which is very curious, of course, that gravity has no force, because why do you call it force? Then yes, but yes, it is so called. Well, it is still claimed, but yes, people do not actually know what gravity is, not real, and so there are all kinds of scientists, so-called and astrophysicists, who in the 20th century and now are still busy in universities to find out what gravity is. How ironic. Can you have it? Because if you know for sure that it exists, why do you have to find out what it is? This is absurd that this is happening in scientific circles, that gravity does exist. It is accepted if it does exist, but meanwhile scientists have to find out what it is. This is really one of the most curious phenomena in the history of science, that this is happening there, that there is still research into what is gravity and how do we measure it. I can't get my head around it. I find it so strange that it happens, but it does happen. It is still there, and there are all kinds of different theories, devices that are supposed to measure it, that are then yes, kind of electrical phenomena, and that would then gravitational particles that come through space, and that pack picks that up, but like, how is that gravity? What does have to do with it? Nothing at all, right? If you have some electrical activity, then that is just electrical activity. That has nothing to do with gravity. It is all very confusing if you look deeply into it. But yes, there is still a lot of research into research people paid to think up all kinds of things, and everyone just lets that happen. Wait a minute. So yeah, well, as a flat earth believer, there are of course alternatives to gravity because the original Newtonian idea of gravity is that everything is pulled towards a center. Pure is relative. How that supposedly works, the idea, despite Einstein, is still held on to. People still cling to Newtonian gravity, but yeah, it does not really apply anymore. But yeah, that bending of time and space. What do you do with that? You can't do anything with it. You can't do anything with it. You can calculate things, but you can't really build models with it. So people still use Newtonian mechanics for their gravity ideas. And yeah, because that's what makes the ball, the earth. Dust is pulled together, and that would then go to a center, and eventually it settles into a ball. But yeah, of course, the pretty no ball black swan shows that that's just not right. And what's going on then? Why do things fall? Down now, not gravity. So there's another theory, scientific theory, and it's been around for quite a while. I even learned it at school, and I'm very grateful for that because the physics teacher gave me the time back then, taken apart, said, yes, gravity is actually that I have to teach you. But that is not actually correct because what is it, density, right? And maybe some of you also learned that separately from, yes, this is how gravity works. That is how you have to learn it. But how it really works, if it has been an enthusiast density, because what is that with density? Another word for that density is the density of a material. The density of a material such as a stone is very dense, water slightly less. Dense air is very thin, or how do you say that? It is thin, you can also call it, and the funny thing is that density, or also known as relative density, is so how that works. Sorry, I am very used to explain this in English, so just relative density, how does that work if an object is denser than the medium it is? And then it goes down, there is a disequilibrium and imbalance between the density of the material, and of the environment that causes a force, a movement, a pressure. If it cannot move, then it presses. And that is how it works. If something denser is then the medium that it is in, it is pushed down. And that happens from within the material itself. There is no field or anything. It just happens. It is a mystery. You can always ask, why then, why then? Yes, we do not know. This is just how it works, and it always works that way. There is no exception, yes, but if something is less dense than the medium it is, and then it goes up. So if you have a balloon, you put helium in it, well, that is a star denser than the average air, and then that goes up, and it just keeps going up until it finds an equal density, and then it stays there, and you can do all kinds of tests with it. You can take a tower with water in it, with oil in it, and maybe even heavier fluids, and then you can throw objects in there, and then you can see what is the density of the object you throw in, because that becomes the layer where it will hang, and that is the density. The density determines whether things go up or down, yes, and that just explains why things fall and go up the way we do know, yes, but then I go to the next topic, and that is gas pressure, because that also has to do with it, yes. Gas pressure is very important to know. It falls under the natural laws of thermodynamics. Gas pressure always goes from low pressure to high pressure, and it does that within the available space a container. If a container were enormous, like, oh, did I say it the wrong way? Oops. Sorry, from high pressure to low pressure, yes. Indeed, yes, and not the other way around. That would be very strange, yes, if there was a very large space like outer space, which is gigantic, infinitely large, then an air pressure, gas pressure would try to spread explosively within the available space, within the available space, until it is completely thinned out. And on average by an even pressure, and yes, that would be if we on Earth were in an open space without a barrier, then the gas pressure would spread with a huge explosion within a fraction of a second, explode in all directions, and never come back, because that space is so vast that the air thins out until it's simply insignificant and no one can breathe anymore. All the oceans would immediately evaporate under the low pressure, because that's what happens. Liquids, if you put them under low pressure, then they evaporate more easily. They expand into gas, and then that disappears too. So, yes, we're not in outer space. We're in a limited available space, a containment, a closed container, because otherwise we wouldn't have gas pressure. Now, of course, there are other influences that also take place, because yes, here close to the ground, the air pressure is a lot higher than all the way up there, and some followers who think that's enough reason to think like, yes, but if it's lower pressure up there, then that lower pressure can just continue forever, and then at a certain point you have the vacuum of space, and that continues infinitely. Yes, but that doesn't work. That's not possible, because radiation within air pressure has certain patterns. So to speak, it has a linear distribution. If there's a gradient within a container, then that has a certain distribute, and that distribution isn't asymptotic. You can have very high pressure for a very short distance, and then lower and lower, and then a huge length of very low pressure. That's how gas pressure never distributes itself under any circumstances, but it can divide into different pressure areas, among other things due to temperature influences. Now, we know that at the ground, it's a lot warmer. The sun's light is absorbed here. You have geothermal energy, and that's heat here at the ground, and that collects here and radiates through. That has a major influence on the air pressure. We also know that from meteorology. But up there, it's all very cold. But how does that happen? There's a cold influence there, somehow. Where exactly does that come from? That's difficult to say, because yes, we do know exactly where there's a barrier, but it could very well be that the barrier is ice cold. That's possible. We do not know for sure, but the chance is high, given the air pressure distribution. But in any case, there's less heat, there's less material that can release heat, so for that reason alone, it's logical that there's less heat, and that will contribute to the pressure distribution, so that explains how the gas pressure works here in the realm of the Earth, and not gravity, because yes, gravity also you believe that is a force which officially is no more than, it would still, what can gravity do as a force? Gravity as a force, when it was still seen as such, was considered as one of the weakest forces in the universe. Gas pressure distribution. Gas pressure that wants to push itself in an open space is so incredibly powerful that it was considered among the greatest forces in the universe, so to speak. So, even if you believe that gravity is a force which officially is no more than it would still not have a chance to push against the gas in any way that pushes of all directions with extreme explosiveness. So that is also not a good explanation for the Bow Earth. It just doesn't work. Their mechanics for gas pressure don't work. And what did they eventually do to try to paint this? Well, then you might have gotten a bit ahead. I did when I heard this for the first time. Ball believers eventually, when you push them and they say, so gas doesn't work as a gas, it works as a liquid, and that explains why gas as a layer on layer should keep float. Yes, air floats, yes it does, it goes in all directions. It won't form layers, and where above that would be the vacuum, but ball believers with their gravity ideas say so gas is a fluid, which means gas and liquid do that both flow. But we just think about it as if it were a fluid, and it isn't, and that's not how it works. And so that whole idea that can float a bit on the ball versus the vacuum is also nonsense. So big problem for ball believers, is also something that Newton with gravity ideas never appealed to, and which is also never really mentioned, because yes, gas pressure law of nature, what do you do about it? It is, it always works, but yes, if you want a ball Earth without a container, yes, then you just have to talk about it. If possible, or turn the whole physics inside out to just get it to believe. And yes, that happens, so I'm curious what the Ball Earth presenter will say about that. Yes, good luck with that, yes. Exactly, well, that's gas pressure, American says. Proof that the Earth is not a ball in space, but confined in a limited volume, right? And then we move on to the celestial, and this is a difficult, complex subject. The celestial, what are these? Lights in the sky, the sun, the moon, planets, and the stars, and also possibly comets and shooting stars to a certain extent. Meteor, that is a complicated story, and that is a story that after 10 years still cannot fully understand. How does E or some other stone with metal in it fall down? I really have no idea, guys. I am not even sure if it is completely real, but yes, whatever that may be, it is separate from the celestial, because what are the celestial? Well, we know, so not the distance. We do not know the size. We only know that there are lights in the sky and that there is a certain angular consistency with those lights. So there is an angular consistency, that is the information that we get from it. If you are at this latitude, then these stars that go from that angle, you go a little further north, then they suddenly go a little more above you. So D has a consistent angular relationship with the Earth, yes. And there they also experience celestial navigation, and I have a video. The fuck you. Yes, nice, fuck you. Music, yes, this is a video from a number of years ago. When I saw it for the first time, I was really blown away, because this is a huge high balloon that is now at 33,000 m high, really very high, and then you get to see things that I am accompanied by, among other things, that reflection of the sun there. Yes, does this look like a sphere that you look at, or an enormous flat surface where you can see very far, and where the sun is reflected like a mirror. What is that? What is? That sun I still don't know. I've been working on it for 10 years, very intensively. I know the more I work on it, the less I really know what the sun is. From where is it? Maybe in the other layer, or something reflection of yes, there are a lot of ideas about, and there are a lot of people who are busy with, oh, it is in the firmament, or there is a kind of a mirror system. There are all people who try to experiment with it to explain what you see, and yes, it is an enormous mystery. What do you find the moon mysterious, Julia's? The moon is much worse, but the sun is so profound because it is so intense light. It is so clear there. And look how much influence that has on the world. All life on Earth is held together by the sun, but we do not know what it is. It is an enormous mystery that all people in all times of the world are staring right in the face, and no one can figure it out what it is. Yes, and yes, they used to think that the sun and the planets were gods. Well, if you find out that we don't know what it is, then you will understand why people might have thought that, because yes, what else could it be? You know, it creates life, but they just can't determine what it is. It is not a light that has placed itself somewhere, because you can't trace it. The crazy thing is that just stay with it. Yes, he can turn off. Now another 25 minutes, oh jizz, really, yo. Have to hurry, I'm only halfway, Oh, hurry up, yeah, there's an issue with the idea of perspective, and now I'm going to criticize flat earth believers with each Deuce's model, because there's a whole group of people who say the sun is 3,000 mil away, and you know it because it goes to the horizon, and it just goes away by perspective. But there's absolutely nothing right about it, because the sun doesn't do that at all. The angular velocity of the sun's movement is consistent. It's the same everywhere. It's the same at the horizon, whether it rises or falls. And right above your head, the angular velocity of the sun is always the same. No, yes. Absolutely yes. No, I know that for sure, because we already have REM proof. No, it doesn't. Perspective is not an lemma, is just how those are the patterns through the year. But I'm not talking about that. I'm talking about night. The angular velocity with which you see the sun move over time is perfectly consistent. If the sun were to move over a flat plane towards the horizon, then just like when you see a car going towards the horizon, or a train, or an airplane, then that goes closer, faster. Angular velocity is greater than if it goes towards the horizon. Goes the closer you get to the horizon, the slower that angular velocity goes, until it suddenly disappears. That's what perspective does to things. Moving into the distance, the sun doesn't do this, the sun doesn't do this, and there are videos going around I've been dealing with for 10 years that say, oh, look, we're here in the desert where it's very hot and the sun is setting, and suddenly it gets smaller. That's because of perspective, but that's not because of perspective. That's its light. Those are, so to speak, lens effects, because of the heat. That's mirage smooth, because the angular velocity of that sun, while it gets smaller, is still the same. So unless you assume that it goes far away all at once and then shoots off at warp speed. Otherwise, that's not right because the angular velocity stays the same, so just because it seems to get smaller, that doesn't automatically mean that it's going into the distance because of perspective, because the angular velocity stays the same, and people easily overlook that for a moment because they really want it to be just 3,000 miles away, and that's how it does because that's how they put it in a think of a model, but the plane is at 10. So sis, miles. Yes, that's much further away, but yes, if above the sun, no, absolutely. There's nothing above the sun, but there's no real distance from the sun. But if you assume the sun has that distance of 3,000 miles, as some people think, which is extrapolated from the angles the sun makes over the flat earth model, yes, perspective still has to take place, and it does not. That's very frustrating. I know. Yes, but do you know how that happens or not? How that happens? Do you have any idea? Yes? Well, that's because there's no location for the sun, which isn't there. The stars, the planets, and even the moon, there are no objects left. It could also be that it's projected upwards from the bottom of the earth. Maybe see that? I don't know how it's projected, but what I do know is that what we're looking at, they're not objects hanging in space, okay, at any distance, okay? Because you're gonna try to follow it. The Hope Cave does not get any bigger, sometimes even smaller. That's very curious. Yes, you're going to follow the moon, and all of a sudden it gets smaller. Well, if it's an object, then that's not right. You can't go there. It's like chasing the dragon, you. Go after it, you never get there. That sounds like a hologram to me. Yes, and that's also what I think it is, and I can explain that further. Yes, 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 I hear it. Yes, that sounds very familiar to me. Fuck you. For let you guys hush for a moment, yes, then we'll move on to another subject. If that's still possible, yes, we still have 15 minutes. Yes, I don't think I'll get it to my Model 18. Minutes, okay, oh, you have a new the video, can go then to the Celestial. Navigation, Celestial Navigation's waited to see, but here, meeting of the Celestia, yes, good, and we'll come back to it. I'm still going to tell you about the holograms. Don't worry, I have a very extensive idea about that, but first we're going to talk about the persecution of this Celestial, that is, Celestial Navigation, something that I used to have enormous difficulty understanding. My parents really tried to push that material under my head, and I was like, oh, okay, oh, but I just don't get it at all now. Really, like, what are you supposed to imagine? Because I was a ball believer, I thought space, so I was in space the whole time, and Star Trek in my head, like, yeah, how am I supposed to interpret this? How this works, I just didn't get it at all, but how does it work, Celestial Navigation? It's actually a very simple system. What you do is you take an angle to a star or the sun opposite the baseline, the horizon, and that angle, that's what it's all about. And you have to determine that based on the horizon. You look, where is the horizon? And then what is the angle between the horizon and the light that you have then? You compare that with the GP data of the star or the sun in question where it should be, because there are certain points on the earth where those stars are the sun, but mainly the stars are the GP points are really about where they pass exactly above you, because those stars, they all make arcs, so to speak, all serve their rounds in the celestial sphere, and on certain points, certain latitudes on the Earth's surface, They're right above you, and that's what it's all about. You have to determine the distance to the GP of certain stars, and if you can figure out what that angle is, you can compare that with the celestial map, and then you know what latitude you're at, what altitude, how north or south you are. And that's been incredibly useful, and that's why we have scouts on ships with a simple device and maps. But how do you do that in a ball of Earth? Yes, that's completely impossible. How do you take a baseline, an angle to a baseline on a ball of Earth? That's impossible. Then you can even enter auto. Angle to a baseline, then it says error, that's impossible. You can't do an angle on a circle. That just doesn't work. But celestial navigation, they could do that with fairly simple mathematics and with maps. They managed to do that because the Earth is flat and the GP map, so to speak, is also flat compared to the well-known map, which can be any way. And if so, that's how the maps were made by, so the angles of the celestial bodies versus the observations of the angles of the celestial bodies at certain places on the Earth. And so you have been able to determine, this is at this latitude, and that is how we are going to divide it, and then you can also do that as a latitude, as a framework, can you that map association. Fuck you. Fuck you.